All right, let's look at number one. So let me show you a couple ways to do number one. The first way I'm going to show, you have to think of it as in only picking a number from quadrant one, and you can test it. So if I chose a number from quadrant one, let's say I chose 30. So this would be cosine of negative 30, which is 330, right? Which is down here, okay? And in this section, cosine is still what? Positive. So I have cosine x. But if I do sine of negative 30, and I put sine here, it's now what? Negative. Negative sine of x, which gives me negative cotangent x. The other way is, if you remember way back when we first started graphing cosine and sine graphs, yeah? You have to remember that cosine is even. So that means if it's positive and it's negative, answer will be the same. Does that make sense? But sine is odd, so it reflects itself. So when you flip a sign, the whole thing flips. Does that make sense? Because cosine is even and sine is odd. Yes? I just picked a number to test, but if you pick a number in quadrant, you want to pick a number in quadrant one, okay, to test. But the other way is cosine's even, so the input and output would be the same. And if you think about that, that makes sense because cosine, all students take cash. When we consider even and odd, so it's the same top and bottom, so over here, cosine is negative, top, bottom. Over here, it's positive, top, bottom. But sine folds over the y-axis, so therefore it is odd. Okay? Or no, that's off. Because folding over the y-axis makes it an even function. All right, I have to think of it a different way. Okay, let's move on to B. So I'm going to factor out a 2. So it gives me 1 minus sine squared x. And then sine 2x is what? Using your formula sheet, what's sine 2x? 2 sine cosine, right? Okay. This I can rewrite to be what? What? 1 minus sine squared is what? I just didn't hear you, hon. Okay, so we have 2 cosine squared over 2 sine cosine, right? Remember that cosine squared is cosine times cosine, right? So 2 divided by 2 cancels. Cosine squared divided by cosine, what happens? Cosine on the bottom cancels, and this drops to just 1 cosine, right? So I'm left with cosine over sine, which is cotangent. Cool? And again, I left off all my, so it was actually cotangent x. I have a habit of dropping the x and the theta. I'm sorry. Good? Questions on that? Okay, so we're on C. Okay, you have to remember that this is the sum formula. Whenever there's parentheses with addition or whatever, you need to expand it out. So I'm going to ignore this for right now. I'm going to leave that alone. So I'm going to have the sine of pi over 2 cosine x plus cosine pi over 2 sine x. Where did all that come from? The formula, the sum formula, which will be given to you on your formula sheet for your test, okay? And I do have those extra copy ones so you don't have to flip back and forth, I think. Okay, so pi over 2 is 90 degrees, yes? So at 90 degrees, what is my y value? 1. So this becomes 1 times the cosine of x, which is just cosine x, right? What is cosine of 90? 0. And 0 times anything is just 0, so it does not matter. So I'm left with cosine x. I'm going to bring down the cosecant. Well, cosecant is really what? It's the relative of sine, so it's 1 over sine. And when I times this together, I get cosine over sine, which is cotangent x. Cool? Interrupt me if you miss something. Cosecant is a reciprocal, the relative. Think back to the escape room the last clue where you had to find the relative. All right, are we good? Okay, the last one. What you should always be doing is, do I notice anything from the start? That they each have a tangent. So I'm going to factor out tangent, and that leaves me with 1 minus cosecant squared. Okay, 1 minus cosecant squared is not 1, but cosecant minus 1 is, right? Yes? Talk to me. 1 minus cosecant squared isn't, but cosecant squared minus 1 is. What is cosecant squared minus 1? Cotangent. So this is just the reverse, right? So we're going to do tangent negative cotangent x, right? Oh, x squared, sorry. Yes? Okay, so that's tangent times 1 over tangent, a negative 1 over tangent squared, right? Yes? This tangent cancels one of these tangents, and I'm left with negative 1 over tangent, which is the same as negative cotangent. Everyone good? So the trick is you have to be careful, remember, when you see parentheses to use the sum or difference rules, okay? You can't just distribute out, okay? Good? Questions on these ones before I move on? All right, I'm going to number 2, and you can watch the replay because I'm recording this, so hopefully the sound works. Okay, so I'm going to do the innermost first. So this becomes 5 times 30, because 180 divided by 6 is 30, yes? So 150 degrees. So 150 is here, okay? So 150 is a 30-degree angle, correct? Yes. And so I am going to do cosine of a 30, which would be the square root of 3 over 2. But in this case, it is negative. Right? And so I want to know, where is cosine negative square root of 3 over 2? Where is cosine negative square root of 3 over 2? The second quadrant and the third quadrant. Well, we already know the 150, which is 5 pi over 6, right? But this is wrong. Why is this wrong? Joshua just told me why it's wrong, because she gave me a second answer, right? She gave me the answer of 210, which is 210, 180. Give me a second, guys. So divide by 3, it is 7/6 pi. So it is wrong because it does not give you all of the solution. It doesn't occur at just one location, okay? All right, good with that? You can't just cancel an inverse cosine and a cosine. It doesn't work that way, okay? And we also talked about that. We use that, and our calculator gives us the answer in the first quadrant, but then we have to use our brains to find out the other locations where it's true. Remember having that discussion? The calculator's not smart enough to name all the neighborhoods. You with me? Okay. All right, so we need to solve this. First thing, is sine squared minus cosine squared a rule? Is it a rule? No, it's not one of our rules. So because it's not a rule and there's a squared, everybody has to move to one side so that the other side is 0. So I have sine squared x minus cosine squared x minus sine x equals 0. This doesn't work for me right now. Why not? What's the issue with the problem as it is? There's two different vocabulary, right? I have sine and sine, but then I have this cosine. So how else can I rewrite cosine squared using sine? 1 minus sine squared. Now be careful. It's a minus in front, so you have to put whatever you're subbing in, please use parentheses. So then we have sine squared x, and we have minus sine. So now when I distribute the negative, it becomes sine squared x minus 1 plus sine squared x minus sine x equals 0. Yes? I saw some people's review packets where they just did the minus 1 and they kept this negative. This subtraction is in front of the cosine squared, so it has to stay in front, and you want to sub in using parentheses so that you remember to distribute the negative, okay? So now I really have 2 sine squared x minus sine x minus 1 equals 0. And we talked a couple weeks ago about how that might scare some people. So we're going to write it like an algebra problem. 2x squared minus x minus 1. How do I factor that? What does it have to multiply to? Negative 2 and add up to negative 1. So what are two numbers that multiply to negative 2 and add up to negative 1? Negative 2x plus 1x minus 1. Yes? So these are what you gave me. Okay? Now, what did these two have in common? 2x. What did these two have in common? 1. So my first parenthesis is 2x plus 1. Now we're just going to do the division. What is 2x squared divided by 2x? What's 2x squared divided by 2x? What am I left with? Just an x. What is negative 2x divided by 2x? Negative 1. Let's verify, okay? 1x divided by 1 is x, and negative 1 divided by 1 is negative 1. So did I do it correctly? Okay, so now what do I need to bring back in? Sine. So 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. Therefore, 2 sine x equals negative 1, sine x equals negative 1/2. Now, either using your 0 to 4 chart or the hand trick, where is sine 1/2? At 30. At 30. So I know 30. So if I think of all the 30s, that's 30, 150, 210, and 330. But because it's not positive and negative, I have to look for just the negative. So I really quickly do all students take cash. I want the negative, so those two are gone. So I want the third and the fourth. So 210 and 330, yes? Cool? Okay? And over here we have sine x equals 1. Remember, when it's 1 or 0, it's one of the axes. So where is y positive 1? At the northern axis, which is 90 degrees. Cool? Coming back to you? Okay. If not, rewatch the video, and there's other videos on this, okay? All right, next one. You simply have to type in your calculator 7 cosine 121, 7 sine 121, and then we have 4 cosine 135 and 4 sine 135. Okay, when I typed those in my calculator, I got negative 3.6 comma 6, and for this one I got negative 2.8 and 2.8. You might be slightly different based on how you rounded, right? How do I take that and get it to a single vector so that I can do magnitude and direction? What do I have to do? Terminal minus initial. So it is going to be negative 2.8 minus 3.6, which ends up being 0.8, because when you subtract a negative, it really becomes positive. And then I'm going to do 2.8 minus 6, which is negative 3.2. Yes? What do I do with these two numbers to find the magnitude? Square them and add them, and then square root. Yep, so negative 3.2 squared. And I square root that, and my magnitude was 3.3. Cool? How do I find the directional angle? It's like slope. What trig word goes with slope? Tan. So inverse tan of Negative 3.2 over 0.8 gives me how many degrees? Negative 76 degrees, and you can leave it as a negative angle. It's fine. Cool? This should be one of the easiest problems you have to do. Okay? So we simplified this to a component. We had two components. We subtracted the components, got a single component. We found the magnitude of the component by squaring each piece and summing it up and then square rooting. And then we did basically we did the slope of the component, tan inverse. Good? All right, almost done. Now we're at the pumpkin tossing. I did change the problem and made it a little bit easier, so I don't know if you marked that, but I want to know if the pumpkin clears a wall that is 125 feet high, 350 feet away. So my x equation ends up being 125 cosine 45t, right? I can replace x with what? 350. Okay, remember the length is x and the height is still y, and t is like z. It's the third dimension. Equals 3, what was this? I'm trying to remember. I'm sorry, I forget what this ends up equaling, but I know t ends up being 88 after I do 350 divided by this. Okay? Yeah. Oh, sorry. Yes, this is 88, and then I got 4. You are right. T is 4, yes? 350 divided by 88 is 4. Okay. Then I did negative 16 times 4 squared plus, it was kind of cool because 125 sine 45 is also 88. Why is that? 45, if you think of a 45, 45, 90, you have two matching pieces. So sine and cosine always match at the 45s, other than one might be positive and one might be negative. Times 4 plus 25, and I typed that in my calculator, and I cut my numbers off, so I got 121. I know some people got all the way up to like 123, depending on they extended these two numbers a little bit further. But regardless, is it going to clear that wall? No, it's not going to. It's going to get very close, but it's going to miss clearing the wall. It's going to clip the top of the wall. Yes. Yes. I did not write that up here, but you say, no, it does not clear. Please also remember that when you're checking clearance, you round down, not over. Like if it's trying to go over a target, if you're trying to figure out if a truck's going to fit under a target, then that's when you round up. Does that make sense? When you're little, you were taught always 0.5 round up, less than 0.5 round down, but you're going to learn in your life that you have to round based on the situation. You know, if you're ordering buses and you have 2 more kids, you got to round the bus up. You know, you can't. Cool? All right, number 6. Number 6, I quickly drew a triangle, and it doesn't matter. Your triangle might have been different. What did I do? I did 40, 46, 63. You could have had them in a different order. It's perfectly fine, okay? What's important is you should have learned in geometry that the height is always what to the base? Perpendicular. So here's a lovely perpendicular line, okay? And if I want to find the height, then I need to know one of these two angles. So I went ahead and found this angle here using the law of cosines. So if I want to find this angle, I'm going to start with this. So I'm going to have 46 squared equals 63 squared plus 40 squared minus 2 times 63 times 40 times the cosine of x, okay? And so 46 squared ends up being 2116, and the combination of this ends up being 5569 minus 5040 cosine of x. I'm going to subtract this, and that gives me negative 3453. I'm going to divide it by the negative 5040. And I'm going to do inverse cosine y. Because I'm trying to find the angle, and it ends up being, I rounded it to 47 degrees, okay? So this ends up equaling about 47 degrees, right? Okay, if the height is perpendicular, then what trig can I now use? The easiest trig, the trig we love. I can use SOHCAHTOA, I'm going to use sine, right? So I'm going to use sine because I'm looking for opposite and I know the hypotenuse. This 40 is the whole length. I can't use it because I don't know if this bisects it, okay? So I would do the sine of 47 equals x over 63. How do I solve that? 63 times sine of 47, right? The opposite of division is multiplication equals x. I typed that in my calculator and I got 46. I got that x was 46, okay? And area of a triangle is half the base times the height, or base times height divided by 2, however you want to do it. So half of 40 is 20 times the height of 46 gave me 920 feet squared. Cool? Was there a question? How I found the area? Okay, so area is I do half the base. That's why I chose the even number for a base of the three numbers. So half of 40 is 20. The height ended up being 46. So 20 times 46. Or you could have done 40 times 46 and then divide it by 2. I don't care how you do it. Okay? You still would have gotten 920. Everyone good? All right. Last problem. All right. So this is a donkey, and they give it away with this kind of imaginary line. So you have to pretend that that's not there at first, okay? Or use logical sense when you do the problem, okay? So I have a pair, and because I have a pair, I can use law of sines. So I have sine of 33 over 6 equals sine of y over 10. Everyone with me? Okay. So to solve this, I'm going to do the inverse sine of 10 sine 33 over 6, and that gives me what? I saw it on a lot of people's paper. 65. Now, I saw a lot of people write 65 right here. What type of angle is this? Obtuse, so it can't be 65. 65 is actually the y. Y is 65 degrees, okay? And we learned law of sines. When you find this, you also have to find its what? Linear partner and see if it still built a triangle. Okay, so let me erase some of this for a second. I'm going to highlight two lines. Ooh, helps if I'm on the pen. This line and this line, what do you notice? I know it's not drawn to the best, but what do you notice? They're equal. So if this guy is 65, then this guy has to be 65. Oh, and you remember how I kept telling you we have to look for the linear partner when it's a donkey? Yeah, linear pair. Because I don't know if it bends in or bends out. So who's the linear partner for 65? 115. They give it away with the picture that it's a double donkey. Cool? Easy? That is the end of the review.